Okay, folks, so I'm going to leave you guys to work number 3 by yourself, but I'd like to show you a hint for part B here. Okay? Technically, you could go ahead and evaluate part B as it stands. Okay? So one thing I would recommend doing for this is going ahead and expanding or foiling out the integrand. You could also do a U substitution on this if you know how to do that. But if you're unsure, or if you prefer, I think this is actually the better way to do this problem. So if we FOIL this out, we get 8x cubed minus 12x squared plus 2x minus 3. So if I wanted to, I could go ahead and evaluate this antiderivative from the lower limit of integration of 2 to the upper limit of integration of 0, and then multiply my final answer by a negative 1 to evaluate this. But if I wish, and most of us prefer to do this, I could reorder this by rewriting it as the integral from 0 to 2. Now what did I just do? I did two things at once. I reversed the limits of integration here in this problem, and in doing so, remember that to do that we have to then multiply the integral by a negative 1. And so that's how we end up with a positive sign in front of this definite integral. So this is how we could rewrite this problem. And at this point, I'm going to let you do the computations of this. I don't think there's any new material here, so I'll let you go ahead and find the answer for this. So now we're going to look at evaluating a pair of integrals, and we want to make some generalizations based on what we see here. So before I go ahead and find the definite integral from -2 to 2 of this function, let's go ahead and sketch this parabola. So the graph of this parabola looks something like this. Here is the function 3x squared, and what are we being asked to do here? We're being asked to compute the area underneath the curve, the net area, from -2 to 2, which I've represented by shading blue here. So we've been asked to compute this area, and we want to do so using our definite integral. Well, and I don't know if this is a big help, but what we could do is we could go ahead and rewrite this, and one way to look at this problem is rather than computing the blue region, what we're going to do is we're going to compute this green region that I'm shading right here, which is exactly 1/2 of the total area, and then we're going to double that. So rather than computing the blue region, we could say that's equal to 2 times the integral from 0 to 2 of 3x squared dx. Okay? So this gives me 2 times, and then if we evaluate that antiderivative, we get x cubed evaluated from 0 to 2, which is equal to 2 times 2 cubed minus 0 cubed, which is equal to 16. So notice what we did is we computed the area of this green region, which came out to be 8, and then we doubled it to give us a total area of the blue region, which is, let me be careful with the word total there. By total, I mean the sum total of the two regions, of 16. Okay. So in this case, we were able to say, rather than solving this integral, we can solve this integral right here and then double our answer. What is it that enabled us to do that? Well, there were two things. First of all, and don't overlook this, first of all, the upper and lower limit of integration looked like this. They were both the same, so they were, the two limits of integration were equal but opposite in sign. The next thing is there's something special about this function here. This function, the only reason why I was able to do this is because this function is symmetric about the y-axis. But which functions are symmetric about the y-axis? The even functions. So, and just for your notes going forward, I'm going to put this down here. If f is even, then the integral from minus a to a of f of x dx could be calculated, and you don't have to do this, but this is a permissed alternative method of finding this, is by taking the integral from 0 to a of f of x dx. That computes exactly 1/2 of the net area, and then doubling it by multiplying it by 2 out front. Okay. So let's look at number 5 here, and if we were to sketch part of number 5, so 5 is our sine function, which is periodic and it continues on forever, but we'll just sketch part of it, and it continues on in this manner. But we're being asked to compute what? In this case, we're being asked to compute the area from minus pi over 2 to pi over 2. And so we're being asked to find the area of this. Let me go ahead and again do it in blue. This region right here. Well, if we remember how our net integral or our definite integral was set up, it was set up by using the limit of Riemann sums. And so for every rectangle that I have right here that has a height of some positive number, I've got another rectangle right here. It's equal but opposite in sign rectangle, which will give a total net negative area. And those two will cancel each other out across the board. And so what is this integral here? This integral is just 0. By the way, you could compute this a long way if you really wanted to. So let's go ahead and just do that. We'd have the integral from minus pi over 2 to pi over 2 of sine of x dx. And antiderivative of the sine of x is the cosine of x. And we're going to evaluate this from minus pi over 2 to pi over 2, but that gives us the cosine of pi over 2 minus the cosine of negative pi over 2. But both those sums come out to be 0. Both those expressions come out to be 0, and we end up with a net area of 0. But again, I think a more sophisticated way of arriving at the answer of 0 was to recognize what? Well, first of all, this function was symmetric about the origin. Notice that this point right here, if I reflect it over the origin, has an opposite, a counterpoint, if you will, on the other side of the origin. Same thing, let's say this point right here has its counterpoint maybe over here. This point right here has its counterpoint over here, etc. So this function is symmetric about the origin. Which functions are symmetric about the origin? Those are the odd functions. So if your function's odd, and if your limits of integration are the same, then whatever region you construct, you're going to have an equal but opposite region on the other side of the axis, and so those two, if we're summing from minus a to a, will cancel one another out and we'll get a net integral of 0.